Hello and welcome to Bay College's Intermediate Algebra online lectures. This is section 6.5 that deals with radical functions. Sometimes we can have radicals as part of functions. Essentially, what we need to have in order for that to take place is for every x value, it only corresponds to one y value. Hopefully we recall a little bit about functions and what does that statement actually mean? It means it would pass the vertical line test. Meaning that it is a function. So each x corresponds to only one y value. And essentially our radical function is going to have this form, f of x, hopefully we recall the notation, equals the indexed root of some radicand, which contains our variable. What are we missing? What are we actually graphing in this case? So it's going to have this form, and hopefully we recall our function notation. So let's essentially just look at an example. Here we have f of x, our function, our y value, equals the square root of x minus 1. Well, one way to graph this is to just start plugging in some values. But the most important thing, whenever dealing with functions, and especially functions that contain radicals or x's in denominators, identify the domain. What do we mean by domain? Well, hopefully we recall at some point in our math we talked about domain. Domain are the values of x, and I'll just put right here in quotation marks. We have an x. It says what values of x can I actually plug in here to get an output of a real number, something that's tangible. Well, what do we know about radicals? Well, square roots or even powered roots can never be negative. So whatever's in here has to be greater than or equal to 0. Well, this is our tool to find domain when they're in functions. Whatever is under that radical, our radicand is x minus 1, it has to be greater than or equal to 0. So if I solve this inequality, I just add 1 to both sides, and I have x is greater than or equal to 1. This is my domain. And in proper function notation, we write x such that x is greater than or equal to 1. Or in interval notation, we'd say 1 to infinity. So either one of these is our domain. For me personally, you can just write that. That is my domain. X must be greater than or equal to 1. So as long as x is 1 or greater, I'm not going to have any imaginary or unreal values that I can't graph. So as an example, if we try to do this, what if I put in 0? Well, 0 minus 1 is negative 1. What's the square root of negative 1? Well, I can't take the square root of a negative at this point, so there is no real value. So obviously, a negative value isn't going to work for x. That's what we just determined. That's its domain. Now, the next thing we're going to look at is for range. But at this point in the class, it's a little bit easier to graph it. But just to tell you what range is all about, it's saying what are the output values of a function? What are the y values? So let's go ahead and let's start graphing this. We know we can graph it just by plotting some points, but the points we have to start with have to be within the domain. That's why this is the first thing you find. What's the domain? What are the values of x we can actually use? So we know x can equal 1, so let's start right there. That's our starting point. If I put 1 in here, 1 minus 1 is 0. So I'm finding f of 1, and when I plug that in, 1 minus 1 is 0, the square root of 0 is 0. f of 1 is 0. This, in function notation, is basically telling me the point. When x is 1, y is 0. This is the point 1, 0. All right, and now if we find another point, well, we know x could possibly be 2 or any value in between there, so we plug in 2. 2 minus 1 is 1. What's the square root of 1? 1. So when we have 2, our output, or y value, is 1. So this is the point 2, 1. All right, let's pick another value. And just write my values down. I picked 2 and I got 1. Now, I'm going to be a little selective about the next value of x I put in because I'm dealing with a square root. I want this to be a perfect square. So maybe I'm going to choose 5, because 5 minus 1 is 4, and I can take the square root of 4. So I'm going to say f of 5. And if I plug that in, 5 minus 1 is 4, the square root of 4 is 2. So this is my x value, that's my y value. The y value is 2. So when we put in x of 5, we got a y value of 2. So 5, 2 is my other point. We can kind of see a pattern here. As I go further to the right of my graph, it's going to kind of level off a bit, or seem to level off. So this is my graph of my function, just by plug and chug. All right. Later in the course, we'll actually learn about library functions, a great tool, and transformations and things of that nature, and it'll make graphing things like this so much easier when we get to that point. But we can graph it just by plotting some points, and we can see because it's not a line, we had to have more than just 2 points, so we continued on there. So this is the graph of our function. Now, once we have the graph, we can visually determine what the range is. Essentially, range is saying, what are the y values? What's the lowest y value? What's the highest y value? Well, if we look at this, the lowest y value is 0. There is no values that are negative for y, because the square root of a number will always be positive, right? So that kind of makes sense, hopefully. So y is going to be greater than or equal to 0, because at this point y was 0. It was actually equal to 0. And any value above, because as this line actually continues on to infinity, it does increase ever so slightly on to infinity. So it goes on and on and on. So y is greater than or equal to 0. If I wrote this in interval notation, it would be 0 to infinity. So these are domain, the x values that are part of the function, and the range are the y values that will be our outputs of our function. All right, just to confirm that we understand our function notation, and maybe we're not graphing, maybe we're just asked to find a specific value. What does this mean if I have f of 2? Well, the function notation says in place of the x value I have 2, so what I need to do is in place of the x I put in 2. And that's essentially what we did when we went to graph it. As you can see here, when we plugged in an x value of 2, we got a y value of 1, an output of 1. So the square root of 2 minus 1 is the square root of 1. 2 minus 1. And the square root of 1 is 1. So when I plug in a value of 2 for x, I got a y value. This whole thing is y. F of 2 is 1. 2 of 1. So you're going to have to recall how to deal with function notation and work through it. That's been a relatively short video, essentially domain, range, graphing functions, and evaluating them for specific values. This has been section 6.5. Thank you for watching.